Alright, in this video we're going to talk about some of the different quantitative displays you can make. We're not going to hit them all in this one, but we'll hit a couple of the main, most common kind. When you're talking about a dot plots are good for displaying quantitative data for a relatively small number of discrete values. So again, discrete, we'd want something countable. If you have a bunch of different values that have a bunch of different kinds of decimals, it's hard to get down here where they would go. Plus, dot plots are only really good to tell us much about shape if you have some repeated values and some stacks of dots. And if your values can have all sorts of different decimals, then it's harder to see the difference between them. So, suppose in a class of students we ask how many siblings each person has, and we get the following data. Well, all we really need to do is look at the numbers. The numbers go from 0 up to as high as, actually, it looks like it only goes to 4. But then our graph is really just a number line along the bottom. It might be a number line that has some decimals if they went to like the nearest tenth or something like that. And then all we need to do is count. We have 1, 2, 3, 4, 5 zeros. We have 1, 2, 3, 4, 5, 6, 7, 8 ones. And then just keep on going. And you're just putting a dot above each of those values until we're done. Next is a stem plot, or sometimes it's called a stem and leaf plot. Stem plots or stem and leaf plots are really good for quantitative data. And the way it works is the stem is all but the rightmost digit. And then the leaves that are usually out on the right are the final digit. So, for this data, I asked a group of students how many different states they had traveled to. And this is what they said. So I have numbers that go from single digits, as low as 1, all the way up to 50. So for my stems, I want to use the numbers 0 through 5. And even if you have values that aren't hit, like I don't have any values in the 40s, among your stems, you should not skip any values. If they end up blank, they end up blank, but that gap in the data where that number is blank, that's important for us to see. And then we just look on the right-hand side. Now, for the single-digit numbers, the only way to make that a two-digit number like the rest of them is if we put a 0 in front. So 1, 3, 4, 7, 8, 9, we're really counting those as 0, 1, 0, 3, 0, 4, 0, 7, 0, 8, 0, 9. Then in the teens, I have 12, 13, 15, 19. In the 20s, I have 21, 22, 22, and 23. Then 30, 34, and 50. So this would be my stem plot or my stem and leaf plot. The key is it says every stem plot must have a key. So we need something like this that shows that when you see 2, 1, that really means 21. Now, it doesn't actually matter if this is one of the numbers in your list. I could say that 4, then the line, then 1 means 41. That's just as valid as the key. The reason it's so important, though, is we need to know whether these numbers represent numbers that are in like the 10s, 20s, 30s, 40s, or it is just as valid that we might have a set of data where those are decimals. Or you could have one where you actually have it even smaller than me. They're like percentages. So, and all of these, no matter what the key looked like, the graph wouldn't change any. So we need to be sure to have a key to show what our decimals are. You can go bigger than two-digit numbers. If you wanted to go into the hundreds, you would just have 2 digits for every stem. So you'd have like 0, 0, 0, 1, 0, 2, all the way and up. Then when you got to 0, 9 for like 90s, then you would go 1, 0. You'd have a 10 there for 100 and whatever. And then 1, 1 for the 110s, and 1, 2 for the 100s and 20s, and so on. Now, sometimes we create an expanded version of our stem plot by doing something called splitting stems. So here's a stem plot. Here's our key about caffeine in different beverages. Because there's so much data here and it's so compressed together, we might make what's called a split stem plot. And basically what we do is we take each of these stems and we write it twice. So 1, 1, 2, 2, 3, 3, 4, 4. And now, instead of all of the 10s going on one line and all of the 20s on another line, we split the digits exactly in half. And we need to be very careful about this. My top line, the first one, represents 0 through 4. So the first one that occurs there, or the first two that occurs there, or the first three, those are always the digits 0 through 4. And then the bottom line represents the digits 5 through 9. So 3, 4, 4, those would all go in the first line, and there are no numbers in the upper teens. I don't have anything that's 15, 16, 17, 18, or 19, so that one would be blank. In the 20s, the 0, the 3, all the way up through my 24s would be in the first line. Then 25 through 29, those would all go on the second line. And you keep on going all the way down. Now, the advantage of this is we actually get a little bit clearer or more detailed picture of what's happening. In this graph, we look at the one shape and go, okay, there's a peak in maybe the upper 20s. In this one, we actually can see there's a peak in the upper 20s, and then there's another, it's a little bit smaller, but there's another peak in the upper 30s. And when we're describing data, if there are two peaks in the data, we would want to note that. And we'll talk more about shape stuff in a later video, but that's why we might split stems. You should be able to make both kinds. If they don't specify which one they want, then you can choose. But if they do ask you for specifically a split stem plot, then you should give them that. The last kind of graph we're going to talk about in this video is called a cumulative graph. And you can have a cumulative frequency graph. You can also have a cumulative relative frequency graph. And the only difference is whether there's a number count on the side of how many data points you're talking about, or like this one, whether there's a percentage on the side. To use a cumulative graph for either kind, what you're going to do, it depends on how the question's worded, but you're either going to start down on the x-axis at some given score they're asking you about. So maybe I'd start down here at 30. Then I would trace up, and from there I would trace over. And wherever I hit the y-axis, that would tell me, in this case, the percentile of where a score of 30 would be. If this were not a percentage but a count, if this was a frequency graph, then it would tell me how many people were at that spot or lower than that. But almost all the time when we see these, it is as a relative frequency graph. So some types of questions you might see. If another student got a 32, what percentile would they be at? So the idea is I started a score where a score of 32 would be. And this one's not super detailed. They didn't give you like tick marks for every value. So just do the best you can. But I would trace up until I hit the graph. And then I would trace over from there. So in this case, it would be somewhere around the 23rd percentile. Now with a graph like this, as long as you're close, you're fine. If they want you to be super detailed, they'll make their graph a little more detailed. So if you had the 22nd or the 24th percentile, that would be fine. B, what score corresponds to the 90th percentile? Okay, well this time we're starting with the percentile. So I would go up to where the 90th percentile would be. I would trace over until I hit the graph. And then I would trace straight down once I hit the graph to get my score. And again, there's a little bit of wiggle room depending on where exactly you hit. Somewhere around 51, 52, somewhere in there would work. And then last but not least, where is the center of this distribution? Well, the center of the distribution is the 50th percentile. And we'll talk a little bit more about that later in the chapter. But when you want the center of something, the 50th percentile is the middle of all of your data. So if they want the center of the distribution, we just need to go trace over from 50, trace down from where we hit, and that would give us our score. So somewhere around the 42, 43 range. That's it.